Let's go through LeetCode 3068. Find the maximum sum of node values. For this question, it gives us a tree, undirected tree with n node. And it gives us an integer array. Those are the values of those kind of n node. And there is give us another k in the edges. We can choose any edge in the for example, this edge which is U and V, and with node U and V, and update the nums U equals nums U XOR K, nums V equals nums V XOR K. And we can do as many times as we can and choose any edges and return the maximum possible sum of the values by performing those kind of operations. So for this question, if we see a tree, right? It gives us those kind of edges. We can do XOR the nodes of any edges as many times as we can, right? So if we have a tree like this, so we know trees are actually connected. So for example, if we have a node U is here, right? Let's call node A, right? And node B is here, right? And the C, D, E, right? If we only have H, A, B, B, C, C, D, and C, E, right? We know trees are actually always they are connected. If we select edge, for example, edge AB, right? That is nums A XOR K and nums B XOR K, right? And then if we select BC as well, right? Then we have nums B XOR K, then XOR K, right? And have nums C XOR K. So we'll see this nums B XOR K twice. That means that is the same effect as nums B. We do not do any XOR, right? So in this case, we are able to that is the same as if we have an H like A and C, right? And we are doing XOR A nums A with K and XOR nums C XOR with K, right? So that means this H is actually not useful, right? So for trees, because all of the nodes, they are connected, we'll see, for example, if we want to see B and E, right? That is the same thing, right? We have B, nums B, XOR K, nums C, XOR K, right? And this one, XOR K again, and the nums E XOR K, right? So this XOR K twice, that is the same thing as nums C does not do any XOR. So that means we can also we can consider that there is a B connected with E as a edge, right? So that means for the tree, any two nodes, we can select any two nodes to do these kind of operations. These kind of operations here, right? So we don't need to follow those kind of edges because those trees are connected. So we can select any nodes to do XOR. For example, if we want to select AD, right? We can consider like AD, there is an edge between them. So in this case, what we do is that we just trying to XOR all of the numbers with K, trying to see whether they are increased or not, right? So there is one limitation is that we should select by ages, right? So at the end, we are going to XOR even number of numbers, even counts of nums, right? And so if, for example, for these nums, if we every number, right? If it's XOR, it is an increase. We should intuitively is that we should add to our final sum, right? Add the new XOR. And if it is decrease, intuitively we think about is for this XOR, we should not add to our final result. We just use the original nums, right? But there is one thing is that if this is even number, increase that is the even number. So what we think about is we should find the smallest delta increase, right? And for the decrease one, we also find the smallest delta decrease, right? We try to see compare the value which one is greater, right? So if the smallest delta increase is greater than smallest delta decrease, so we should add this pair, right? So the smallest increase and the smallest decrease, we should add this pair. Otherwise, we just ignore this kind of smallest increase pair. So at the after this analysis, we just write code for this. Long restart, right? Yeah. So what we do is that we should count, right? Because we need to know the increase number, whether it is even or odd, right? And we should have an increase minimal diff. This is the delta value should always be positive, right? So that we set this as the integer max value. And decrease, we should also have a minimal diff, right? That is also has integer dot max value. In this case, we just put into num in num. We should have new num equals num XOR k, right? So we'll say if new num greater than num, right? Intuitively, we have result should add equal to new num, right? And we should have counts plus. And also, we should update trying to find the minimal delta, right? So we should have minimal diff equals max dot min I minimal diff, and this new num minus num. Else, that means if our new num is get smaller, our result should add equal to the original number, right? We should not XOR k. And we should also have decrease in diff equals max dot min decrease in diff. This should be num minus new num. So the thing is that if this kind of counts is an even number, right? Then we just return this result. But if this is odd number, we try to see which one is bigger, right? And yeah, so if this one is greater, right? So we should include this kind of decrease. It should be our sum minus d min diff, right? And if this one is greater, right? That means for the last increase one should not include that. It should minus I min diff, right? So the result should be return max dot max on result minus I min diff, and the result minus D min diff. And let's write the Python code as well. Result count I min diff D min diff equals 0, 0, float IF and float IF. So we should for every num in nums, right? We have new num equals num XOR K, right? So if new num is greater than num, our result add equal to new num. And let's have count, right? Count should class equal to 1. And let's have the I min diff equals min I min diff and new num minus num. Else that is result to the plus equal num, right? And we have D min if equals min G min if in the num minus new num, right? And in the end, the since there are if this is even number, right? So if count mod 2 equals to 0, then we just return result. Otherwise, this is if this is otherwise this is odd number. Just return max result minus I min diff result minus D min diff.